Welcome to CodeInbox Automation Lab. This is Sharful. In this lecture, we're going to learn very basic concept about manual testing. So we'll learn from the very scratch. Like the first, we'll learn some testing concept, and after that, we'll learn like how to implement those concepts in some real project, like some demo project. Okay, so it will be number of tutorial. So the first tutorial we'll see the testing concept, and then there will be another tutorial we'll see in applying those concept like testing concept with some demo project, so that we have overall into an idea and some knowledge in regards to manual testing. Okay, so here is a class will be divided in two parts. So one part would be a testing concept, like the very basic testing concept from the scratch with some definitions, some and the testing life cycle, all those things with the parallel software development life cycle. So probably you already know it, but still we'll go through so that it's we can start from the scratch. That will be, so first part would be the testing concept, and second part would be implement of those concept with some demo project. Okay, implement of those concept with the demo project. So here we'll learn probably not all of the concept we'll able to implement, just we'll use couple of them, but at least we'll break down like how to write the test cases, like all the steps, and then what would be the format, then when we'll file a bug, what would be the format of the filing a bug, and what's really happened in real life. So we'll use one of the project, and then within this project we'll try to use some of the concept that we're going to learn from here. But here in concept section we'll try to explore as much as possible all the detailed concepts, so that we have overall idea about the manual testing. Okay, so first is software. So what is software? The software, it's a simple, it's a program like which is give you some specific outcome. So it's a developer, usually number of people or single people, they develop or they do a program, and based on for doing some specific outcome, some specific job, so that it's benefited people, right? So this is very simple software definition. And the software in the market is usually we define software in two different ways. One is called the product, another one is called project. So this is only the two two different way people that developed when there is the software needs to build. So what is product and project? So product could be a software or service, we know it's but it aims to meet a specific need and will require ongoing maintenance and upgrade. The product teams therefore stay together for a long time to build, run, maintains, unlike project, which are build the result. Product are about the journey. There is no known endpoint, and participants are learning as they go. So basically it's a product. It's specifically if we talk about, say, Microsoft, they build the product based on the market analysis. They analyze the market, and after that, based on the market needs, they build their own product. And then they have the long time team who's like responsible to update the product, maintains the product, and then people that subscribe those products. So that's the example of the product. So most of the big company, the Google, like the Gmail, it's a product, right? So like Office, Microsoft Office is a product. On the other hand, what is the project? Project usually is a way of executing an idea. In practical terms, with a project you need to understand a lot of things before we start, like what time, the money, budget, people are available, all those things we have to analyze before we start the project. Usually the project it's a little bit smaller than a product. Like example, software development company, and the user or end user came to the company and they said, okay, I need a software, to build, right? So or I need a web application, or I need a website that you need to build for my company. So those are the specific projects. So the company, they take the order and then they build the the project or product as per the clients require, and when the project is done, so the team is go away. So it is a short term, right? It is a short term plan and focus on a specific scope. So we need to, based on that scope, the company, they allocate the resource, they allocate the time, they allocate the budget. What would be the budget? It has some start time when the project should start, and when the there will be some deliverable time. Okay, so that's the in time, and which is very specific. Like in a product, there is a in time. It means there is a deliverable time. Like it's a deploy some different version, but it's not a stick that time. Like the project, because project it's a request from the direct from the end client. Okay, so this is the two terminologies in software industry, which is the product and the project. So your company could be based on the product based company, your company could be project based company. Like the big company, as I said, Microsoft or Google, all are basically, it's a product based company. Or some software development company, there could be the project based company, who takes the order from the end client. Okay, so based on the end user request. So this is the two types of terminology, or you can say two types of different types of software industry. So now when they build the software, so definitely there is a way to build the software. So to build a software, there is a number of activities involved. Those activities is called software development life cycle, right? It is a sequence of activities that carried out by the developer to design and develop high-level quality software. So which is the software development life cycle. We'll learn more about the software development life cycle, because in the industry, there is a different types of software development life cycle is available, and based on this process, like number of activities, they develop the software. Nowadays, you will see there is a Agile is very popular, but before that there was a B model, there was a waterfall. Okay, so we'll touch all of them a little bit, but we'll more emphasis on the Agile model. Okay, and on the other hand, there is another life cycle is called testing life cycle. So it consists of series of activities carried out by the tester methodologies to test the software they need to build. So this STLC, it's one of the part of SDLC. We'll see. So because in the software development lifecycle, it has a number of phases, and one of the important phase is called testing phase, and testing phase is nothing all together is STLC, or software testing lifecycle, where software testing lifecycle, it has its own number of activities, own number of phase, and in different phase, tester, they do different activities, and all together is called testing life cycle. So let's get back to first a little bit more understanding about the software development life cycle. So at the it's one of the old or traditional software development life cycle model. It's called, one of them is called B model, and then there is a waterfall model, and then recently and most popular nowadays is Agile model. Okay, so we'll see a little bit about the B model, because still people, they don't use that much B model is almost out of market. Some company, they still use waterfall, and most of the company, they use Agile. So but still there is some technique or terminology from the B model still we use during our development life cycle. So what is B model? So B model is a highly disciplined software development life cycle model in where there is a testing phase parallel to each development phase. The B model is an extension of a waterfall model in which testing is done on each stage parallel with the development in a sequence way. It is also known as verification and validation. So here you can see an example of B model. So B model, here is what's happened. In the left side, it's the software development life cycle, and the right side is testing life cycle. So here is the number of phase or activities usually developer they follow to develop a product or develop a software following the B model. So number one is started with the business requirement specification. For any model, any software development lifecycle, this is the first things we need to know: the business requirement specification or client specification. What's clients wants. So this is the rough document that comes from the in client. And after that, there was a product owner or the project manager or product manager. They break down this business requirement to a system requirement or functional specification. The functional specification with the more technical word like what would be the technology, it's like different languages, all other stuffs. So this is called system requirement specification. And after that, there is a high level design. High level design is involved. It's like architectural design. Okay, so there is a two type of design is happen development. One is a high level, or another one is low level. High level all is about the architecture design. Before a software developed, they have to make a plan of what would be the architectural design, like what would be the database design, right? So all those things, what will be the different tier levels, so all those are involved in high level design. And after that, they do a low level design, which is, you can say, graphical design or UX design, right? So what would be the the UX developer, they make some the mock page. So Figma is one of the tools in the market. They use that kind of tools, create the similar type of the page, functions, all those things, so that it's more visible and understandable and easier, and make it clear, mapping with the requirement. So this is a part of the low level design. And after that, the coder or programmer, they code based on this design, right? And here is this is the up until code. This is the developer lifecycle or software development lifecycle following the B model. But in the definition of B model, they said each and every steps, each and every phase in developer lifecycle or development lifecycle, there is a parallel testing steps involved with this. How it's like during the coding time, after during the coding time, they do a unit test. It's a unit test. The unit test usually is done by the developer, because this is a pure white box testing. It's in simply usually nowadays this is done by the completely by the developer, because it's test each and every unit. They write the code, so it's verify the code's logic, internal logic, which is the developer. They are the most aware about the code because they are writing the code. So they want to make sure their code is logically right, they're syntactically right. So this is called unit test. So unit test happen with the developer when they code it. And also it's parallel, it is the parallel, you can say, during the coding, also low level design. And next is for the high level design, there is an integration test. So integration test usually is happen more than at least two component or two module, right? So that is to make sure there's a two module or two function, they can work together as per expectation. So integration testing is happen with the high level, it's a parallel with the high level design. And then there's a system testing. System testing, it's all, we can say, end-to-end testing. It's a whole system. The whole system is working as per the system requirement is explained. So this system testing, it's happened based on the system requirement specification. This is cover all the workflow of the software from the very beginning, from the launching the application, at the very end, probably log out to the application. Okay, so that's the system testing. And all the different type of testing we know, like functional testing, non-functional testing, it's all goes, or API testing, all goes under the system testing. And after that, there was a acceptance testing. Acceptance testing, it's called, that's everybody knows about, it's the UAT. So UAT testing is nothing. It's a user, it's a testing, it's a user point of view. So user, they don't know in details like technology, they don't know about the system requirement, they know their requirement in their own language, which is the business requirement. So they convert their testing in as per their business requirement, and they involve on the testing too. Okay, so it could be that directly the end user, or could be the some other group of your part of your company, sometimes like customer service, they also do acceptance testing. So it's except the developer and testing, there's another type of testing happen before the product deploy to the production or hand over to the customer. There's a testing is happening, it's called acceptance testing. It is mainly based on the business requirement that comes from the end user. So this is the parallel. Acceptance testing is parallel with the business requirement from the customer it comes from. So this is that the B level, they said is a B model. The reason why, because all the verification or development phase have a one testing phase on the right side. It is like a V shape. That's why it's called B model. So from the development phase, the development phase is called verification phase, and the testing is called validation phase. So B model is also divided as two parts. One part is called verification, another part is called validation. So let's say what is verification. So verification, it perform on different type of document, because it's you can say at the beginning there is it's mostly the document over here. Business requirement is the document, system requirement is the document, high level design is the document, low level design is the document, except the coding part. So that's why it's called the verification is part. It's perform the different types of document, or which is business requirement, customer requirement, system requirement, and before software gets ready. The purpose of verification is to ensure the requirements are logically complete, understandable to everyone, and doable. So it is also called static testing. The verification test phase is also called static testing. Why is it static testing? Because all the requirements are fixed. Following the B model, one of the big condition, one of the high, the condition for B model, that's your requirement have to be very neat and clean, clear, and static, not changeable. Okay, that's why B model nowadays is not that much popular, because we use Agile, which is allow customer to change their requirement anytime during the development phase. But in a B model, you cannot change all of a sudden your requirements. So that's why it's called static testing. So there is a testing happen in each and every requirement, like there is a verification has happened. So that's why it's called the verification is called static testing. On the other hand, the validation are the combination of different type of testing, as we know, like unit test, integration, system acceptance testing, and so on. The validation start after the coding phase done based on customer requirement, means software is ready and initial development is done. It is also called dynamic testing, as we testing with a different type of input and also doing different type of testing. So the validation phase is also called dynamic testing, because first of all we're doing different type of testing over here, and also we're inputting different input, and based on different input there is the output will be different, right? So like a example, a logging test, if we need to do a logging function test, we enter some different parameter of input, like sometimes valid username, sometimes invalid username, and output should be different, right? So those are like dynamic input and dynamic output. That's why it's called dynamic. Also it's a dynamic testing. So validation is also dynamic testing. So there is a couple of more terminology during the B model, and even in Agile we use those terminology, like it's called the review, walkthrough, and inspection. So what is the review? So review, review is happen in almost every different aspect. it could be happen verification, it could be happen on validation, it could be happen on even development phase. So it's like you can review your requirement, like the end user giving you some requirement, you can review it. Definitely there's a review happen from the the product owner, project manager, or the development team. They review their requirement to adjust it, to make sure it's understandable, make sure it's technically it's right, or it's doable. So they do some review. There's a design review happen. So when UX designer or architectural designer, they do high level, low level design, there is a review happen right after that, by the other part, by the pure guys, so that to make sure that whatever they're designing, it's right, it looks good. They can give some feedback. So for the code phase, that there is also review happen. When one developer they write some code, there's another peer guy, he also do the code review before it goes to the specific branch. Like there's a dev branch, then there is a testing branch, there is a then a master branch. So before it's finalized, there is a review happen for the code too. And there is a for a QA point of view, there is a test plan review. So there is a for testing, before we started testing, there's the test plan is one of the big part, one of the big activities. So senior tester or senior QA analyst or team lead, they create the test plan. It's a document. It's give you what to test, where to test, when to test, and how to test. It give you a lot of answer. It is like guidebook, right? What we have to follow, the testing team have to follow during the testing activities. So it's give you all this document. So it needs to also review, because if your guidebook is wrong, your team will follow the wrong instruction, right? So that's why test plan also needs to review. And test case, definitely when test engineer or QC or quality controller, they create the test cases based on the test plan. There is a needs to review to make sure that the person who's writing the test cases, he's following the instruction, or he is following the objective of the test plan as per the test plan. So it's whether it's a development phase or in testing phase, there's a review happen all the way from starting to end when a product software developed in the software industry. Okay, so this is lots of overall, this is the the main review happen. Other than the review, there's a few terminology also or activities happen during the development lifecycle. One is called walkthrough. Walkthrough is a formal review for any documentation and happens between multiple people or at peer level. Okay, so one person read and walk through the document, and rest of them go through with to understand and ask the question to make it clear. So no scheduled meeting requires for walkthrough. So walkthrough, usually it's a like there is a it's a formal the meetings. It could happen multiple people. So like when the product manager or the product owner writes some document to build it, so the QA or developer, they said, okay, can we have a formal walkthrough so that you can walk through us and we can understand the document very details in regards to acceptance criteria. And those kind of things has happened all of a sudden, and then product owner said, okay, so let's do it. Do you have a time now? So it is very formal. There's no schedule required to do it. So it could happen between two people. It could happen multiple people too, and it is always happen between the team. And there is an inspection. Inspection is a formal meetings, which is part of verification. It's happened between multiple teams, like all the teams, different teams, especially whole development teams. You can think about like QA, dev, project, the project or product team. They're all gets together, schedule based. Maybe it's once a week, okay, and then and during that meeting, this is the meeting, or even you can say there will be author who read the document, like what's their thinking, like long-term goal, what's their quarter goal, what's their plan about the project, all those things, some analytical report or some documentation. So there will always someone who will lead this event and who will read the document and explain it, and there will be some another person who will write or who will take the notes from that during this from the meetings, like key notes, okay, so that it can share later on by the email to everyone to make sure we all understood clearly and we have some documentation. And there will be some moderator for all the team. So this is the three key responsibilities person play different type of role in inspection. Other than rest of the people, they will listen, they will understand. There will be QA session at the end, to make it clear the whole the meetings, all the agenda. Okay, so inspection happen. It's very high level. Most of the times, it's like probably most of the like a leader is invited, like probably from the QA point, like QA leader, QA manager from the DAP teams, probably DAP lead, team lead or manager or above them, and from the product team, from the product manager, including their manager. So usually it's happen very schedule based, probably every weeks. Okay, so this is about the inspection, and it doesn't matter what development model they're following, whether it's a B model or waterfall or agile. The inspection always happen, walkthrough always happen, all this review always happen. Okay, so who is the developer QA? Up until understand up until this part, we can easily say developer who follow number of activities, number of phase to develop a product or software from the left side, from over here, starting from the business requirement to code, and this is called the developer. And on the other hand, the tester is who involved with different type of testing, following testing life cycle, okay, which is start usually for the tester they start with nowadays they do integration testing. Even though integration and unit mostly is done by the developer, but nowadays integration testing also happen from the testing team too, but mostly it's system testing. Sometimes they do acceptance testing, but the tester team or testing is only happen most of the time is a system testing, and system testing will be break down all different type of testing, like as we said, functional testing, right, non-functional testing, and we know so the non-functional testing could be your like performance testing, security testing, load testing, all those are non-functional testing. And there is a other than that, so there is a nowadays API testing is part of integration testing, but inside the system testing there is a smoke test, we know. So there's a sanity test, we know there is a regression test, we know there is a end-to-end test happen. All those testing is the part of system testing, or all together you can say it's a system testing. So tester perform all those different type of testing. Okay, any question?
No.
I think so you already know it, right?
Yeah, a little bit.
Okay, yeah. I mean, it is just I think it's a good to brush our memories,
Yeah,
like so what's really
I see.
happened, because it's not, even though it's agile in the market, is most of the companies follow, but it's still there is some, you will see some mixed format. In some company you will see that they follow traditional way, and then they move from traditional to the agile, and some of them they follow the agile, like there is a sprint will happen, we'll discuss about the agile, there will be sprint happen, but in regards to the release, they don't follow the agile, they go at like like waterfall methodologies. So it's good to know all of the different the type of development model, and also a little bit breakdown. Even though this is not our core concept, our core things like we'll be learning all the technique concept, testing concept. So but testing concept is also involved with all the development phase too. That's why I started from the scratch. Okay, so let's see over here. So now it's, as we're talking about system testing. as I said, the QA is mainly responsible for system testing if we talk about the manual testing or even automation. So for system testing, or you can say it's called black box testing, because during the system testing they don't see the code. Like so here is a say example. This is a tester. This is application. This is our application. And here is if we want to test one of the function is called logging function, and we're going to test the logging function, logging test. So here we'll pass some parameter to do it. One of the testing parameter would be like valid username. There will be valid password, right? And then invalid username, invalid password, right? So those are the different parameter. This is the one set parameter, this is another set parameter. There will be more, probably nothing, there will be no username, password, what should be. So it's a different type of parameter we're going to, or different sets of data we're going to pass on login function, and we'll see the outcome. So based on this sets of data, we'll see different outcomes, right? So what's really happened, we don't see the code, always see the application. This is our application. We go to the application, launch our application, then there will be the logging function, and then under the login function there will be some username, password box, and then inside the string box, right, we'll enter some sets of data, and based on sets of data we'll get some output, and we'll match those output our expected output. So when there is a output comes through the application when you're during the testing, this is called the actual result, and then we'll verify that actual result with our expected result. So what are we really doing the testing? This is like we're not seeing anything behind the scene, the code. So how the developer they build or use the different type of language or code, HTML code, CSS, then it's a JavaScript, all those different or backend SQL server. We don't see any code. That's why it's called black box testing. So let's go back here. So for doing a black box testing or manual testing, we have to understand a few things before we start the testing. We have to understand very well requirement, because the requirement is one of the key part for doing testing, whether you do manual testing or automation testing. So it's a requirement, so we have to, because if we don't understand the requirement, how are we going to test? What are we going to test? We know it's okay, we're going to test the manual login function, but we have to understand the requirement. Is that a login function? What is the requirement? It's is that a accept, like how many digit? Is that what is the combination of username should be? The requirement should tell you that okay, it is accept 4 to 8 character, and a to and a character should be mixed combination, like it's one is uppercase and mix of them lowercase. Those are the requirement. So if we don't understand the requirement, our input, our testing data would be the wrong. So that's why we have to understand very well requirement, and based on the requirement we have to create our test plan. So we know the requirement, then we'll create a test plan. As I said, it's a test plan. It's nothing. Is a template. It's a guideline where it give you some of the answer, like what we're going to test, when we're going to test, and what type of different test we're going to do, or how we're going to test. Is that a manual test or automation test? From where we're going to test, like point A to B or B to C, what function we're going to test, or what function is going to be out of test. So all those things also will be explained in test plan, and based on test plan we'll do our test design. test design is nothing. It will give you, it will segregate like your testing scenarios. Like if you think about the logging function, it has the two different scenarios. One is like happy path, another one is negative path, like positive test cases, negative test cases, right? So which is the part of the test coverage. We have to ensure in a test design will ensure your test coverage as per your requirement. Whatever requirements is saying, we're writing our, before we write our test cases, we have to find out the scenarios, and all the scenarios have to be mapped with our requirement, at least map with our requirement, at least whatever it's saying. And on the top, we have to cover some negative test cases too, so that we cover some edge cases, we cover some breakdown point for the application. So your test design will confirm those things. And after your test design, it means the scenarios, then we're going to write down the test cases based on the test design, because the test design will tell you the test scenarios. So test scenarios is the prerequisite before we write the test cases, right? So if you don't know the scenario, so how are we gonna write the test cases? That's where you have to know the test design. And then after you write the test cases, we are going to do the test execution. So test execution as per the test cases. So here is one thing, where the writing the test cases, there is a number of tools nowadays available in the market for test management activities, where you write your test cases, you execute, and then you get some report. All those things happen. Also, there is a tool also finding, when you find a bug, you can report those bug. And okay, like we'll see in the one of our example, we'll see there's a Zira is one of the bug reporting tool, where you can, it has a template, and following the template you can write you file your bug during the test execution. And after you file a bug, find a bug, and report them, there is a tracking also, bug tracking activities also including with this. Like when you find a bug, you file a bug, and then also you have to track the bug. It means like you have to retest the bug when the bug is got fixed by the developer, to make sure that that bug is fixed. And also there is a regression happen that time, sometimes that bug, to ensure that bug is not breaking other part of the system. So sometimes we have to do regression. It's usually those kind of request comes from the developer, because developer, they know the place, the function you got a bug, where you got a bug, that bug has some dependency and correlation with other part of the application, so it can affect up there. So those are all about the finding bug reports and tracking. Okay, and also we notice all different type of review meetings happen during the testing event. For because of testing, so when you create a there is a requirement review happen, so when you read the requirement and then you give some feedback, so that's part of the review. So writing, when you create a test plan by the senior QA or team lead, so the upper management, like maybe that your team lead or your test manager, they will review your test plan to make sure your test plan is right as per the requirement, because those are the backbone of your test cases, of your testing activities. If you're wrong on your test plan or test design, you will write the write the wrong test cases, or you will have a less test coverage, which can lead a critical bug in your production. So that's why each and every steps usually review happen, but it really depends on the companies nowadays. Especially in Agile, we don't get that much time, but mostly it's like a waterfall or traditional method. We use each and every steps, there is a review happen. Okay, so this is all about, so up until this, all the activities is a part of the manual or black box technique. And there is a automation testing also. The automation testing is nothing, it's like you automate our manual testing. When you write a test cases, that we can automate, convert some of the manual test cases in automation through the automation script. Like nowadays there is an automation API market, like we know this, we're learning like Selenium, there is a Cypress, there is a Protector before. So there is a and even there's a HP QTP. So now, so those are the automation API tools. Like you can convert your manual test cases, based on different project. Like maybe it's a smoke project, maybe sanity project, maybe regression, whatever your company decide. Also you the availability of the resource. And at the very end, like there will be some generate reports and share that report to the management. Like whether you do manual test or automation testing, there will be some report at the very end after your execution is done, which is called summary report, like test summary report, where it will tell you like for any specific, before any specific release or before any specific the project is done, there will be some summary report from the testing side, and where it will tell you the like the pass rate, the fail rate, there will be the bug, how many bugs you found, how many bug was fixed, all those things. Okay, so those are the all together is called test summary report. So anyway, so for the manual, since we're talking about mainly is manual over here, this is the main activities involved in manual or black box testing. It's called manual or it's called black box testing. Okay, so let's go back to again our and all these steps, all these steps we have to follow when you do the manual testing. It means like manual testing is mainly is, as I said, system testing. And system testing, it's include all the functional testing or non-functional testing. Functional testing, what is functional testing? Functional testing, like if you define it's like one specific function of your application to ensure that it's working as expected, it's behaving or it's giving you output is expected as per requirement. So there's a different type of functional testing we do during our testing phase. Like it could be smoke test, sanity test, end-to-end test, regression test, all retest, all are part of the functional testing. And there was some non-functional testings happen also. There was a performance testing, load testing, security testing, all are non-functional testing. So together, functional and non-functional, these two, it's called system testing. Okay, so when you talk about manual testing, we're talking about all this functional and non-functional testing. Okay, so here is a few things. There's some terminology or some technique we need to know. For example, for functional testing, whether you do smoke test, sanity test, or pure functional test, or end-to-end test, which is all together we can say functional testing. The tester, they use some technique. They use some technique to make it much easier. So example, what I can say, let's see again, let's go back to our over here for logging function. So assume that this is our logging function, and here is our requirement. It's like your requirement would be 4 to 9 character. Your requirement should be 4 to 9 character, and A to Z could be your character. But here you should have one upper letter. That's a minimum requirement. In the between this, you can use one special character. One is special character. Okay, so those are the requirement. So if I want to break down over here this requirement for this logging test. Okay, so one parameter, one set of data would be between 4 to 9 character, right, with this upper and one special character. It should accept. One should be 5 to 9. It should accept. One should be 6 to 9. It should accept. One should be 7 to 9. It should accept. One should be 8 to 9, or should be 9. All the characters, if it's up to 9 character, it should accept. Right. On the other hand, what will be the reject? And the reject would be like if there is a character below 4, like 3 character, it should reject. If it's a character 2, it should reject. right? 2 characters should reject, 1 character should reject, nothing should be reject. If I put like more than 9, like 10 characters should reject, right? If I put 10 characters should reject, right? So it's a number of combination or parameter we can pass to test this login function. But see, this is too much just for one function, one your logging test. We can write, I mean, it's too many test cases. Each and every test case is like action. There will be action, your sets of, there will be some action, one action using some input data, and there will be some output, which is the actual output, and you will verify that actual output with your expected output. So if it's a match, this is a pass. If it doesn't match, it's a fail, right? So we can see over here, if we try to break down this requirement, the requirement is 4 to 9 character, A to Z, 1 upper and 1 special character. Following this requirement, we can write, maybe it's 50 different, at least 50 different test cases. 50 test cases. So it is very time consuming. If I have to write 50 different test cases just for one single function, it is really time consuming. It's not only writing the test cases, but also execute each and every time, and then also make a plan. So it is very time consuming. So what then, how we can confirm the test coverage? So that's why there is some technique in testing industry. The technique is, it's different type of, there is a different type of techniques, right? There's a different type of technique in the industry, so that we have the best coverage, as well as the wide best coverage, as well as less number of test cases. So those technique are called over here. The reason why we write that follow the different technique is over here. You can say design better test case, not avoid exhaustive testing, which is not possible, and also help us to reduce the number of test cases and increase the test coverage. So those are the few different reasons there is a test design technique available in testing industry. So those, what are the test technique? The name are boundary value technique, equivalence partitioning technique, decision table technique, state transition testing. There is a error guessing technique. So those are, sometimes in interview they ask about this, like what is boundary value technique, or what is equivalence technique, equivalence partitioning technique, or they give you a scenario. Say example, you have a field text where it accept 1000 character. How you are going to write the test cases to ensure it has the test coverage. So if you think just in general, like you have to make sure you enter 1000 test character, it should accept. You have less 1000 character, like could be 999, it should reject. You have, if it's 800, it should reject. Sorry, it should accept. If it's over more than 1000, it should reject. No matter what, even 1001, 1002, even 100,000, all should reject, right? Even it's so those are number of test cases you can write, but to get the best output or best coverage, we have to follow this techniques. So during the interview, they wants to know that this different type of technique, like boundary value technique, equivalence partitioning technique. Okay, let's see. I can just I will probably not going through all of them, but I will go through a couple of them so that you have understanding about this. At least 2 of them, like boundary value and equivalence, which is the most famous one. Okay. Which one?
From this blog post, you have mentioned these test design techniques. So I want to know that what actually this means and how to do these things.
Yeah, let's see where this is one of the test design. Like as I said, so there's a few number of the test design technique we talk about. So let's go through a couple of them. Let's go through, I believe, if we go here,
Yeah.
Boundary.
I actually posted the link in the Google message. You can find it from here.
Okay, Google message. Okay, let me see. All right. Okay. Yes. So those are the technique I was talking about, right? Let's see, dynamic. I think we already cover those things, like okay, equivalence. Here is the equivalence boundary. Okay, let me go through. We should have a details, probably. Is boundary. We don't have anything. We should have a details separate. Let me search. Black box technique test design, probably here. Okay. Boundary value testing. So boundary, yeah.
No, I got it.
Okay. So boundary value. Let me share the link. So boundary value testing, it is a process of testing between extreme two ends, like two boundary. Example, here is a, there is a edge field, and it accept value 18 to 56. So what's since it's called name is called boundary, so the test is applied based on the two boundary. One is mean boundary, another one is max boundary. So mean boundary is like example for this edge. It's an example, the mean boundary is 18 and max boundary is 56. Okay, so now here, based on this boundary, our test cases will be designed. Well, so one of the test cases would be, there's a three part. Let's make it one is like below the mean, it's invalid. Okay, from the mean it's a valid, and then the max is the valid, but after the max is invalid. So below the mean is invalid, and from the mean to max is one is valid. That's the valid part, which is the 18 to 56, and after the max is invalid. So this is three parts of this testing phase. And based on this, and all this three part is based on the boundary, like mean boundary and the max boundary. Over here, so our testing design, our test case would be, what is our mean? Mean minus 1. So this is the 1. So mean is like 18, so invalid would be 18 minus 1, which is a 17. So we'll pass like 17 character or 17 age is in regards over here, whatever, if it's a character or number, we'll pass the 17, so it will be rejected. So this is the one test case. And then between the acceptance one, so we'll add mean. In a mean level it should pass, so 18, if we enter the age 18, it should accept. That's 1. Mean plus 1, 18 plus 1, it's a 19, it should accept. And the middle, of between 18 and 56, you can take some random value like 55, 50, 56. There's a couple of test cases you can put over here to make sure the sum of the middle number is accepting, like whatever it's you think the middle ground. And then at the max level, like in your max level, it's your 57 should 57 should accept it, and then 57 plus 1 after the max, like 56 plus 1. 56 plus 1 is a 57, which is should invalid. So that's all. We don't have to do further more test cases like 56 plus 2, 56 plus 3. I mean, it can keep going on. So our boundary value is saying, do some test cases, design some your testing based on the boundary, based on the mean boundary, based on the max boundary. So it's a mean boundary, so do a 1 minus from the mean, then in the mean level, then enter do 1 mean plus 1, then there's a couple of in the middle, and then at the max level do a test case in a max, and then do a test case after one plus after just one after the max. So that's all. So it's maybe all together would be 7 or 8 test cases. That should be good enough, and we can say this is it's covering, this is the max covering, and it's working fine, this function, other than writing number of test cases, okay, like unnecessary number of test cases. So this is the boundary value testing or boundary technique. And if we talk about equivalent partitioning testing, so what's equivalent happen? It's similar to mean, like it's divided, but not it's divided. Usually it's 3 part: invalid, valid, and invalid. So it's make the partition your input, your acceptance. Like if it's a your testing acceptance is the age is 18 to 56. So this input will be divided 3 part. One is invalid part. It's similar like boundary. One is valid part, and then there will be invalid part too. So invalid part would be whatever your the mean value -1. So it should be invalid. It should be rejected. And then there will be some valid part between 18 to 56. You put any number, couple of number, like 50, 52, it should be accepted. And then there will be in another invalid part after the your max level. So your max is 56, just added another probably 1 or 2. It's easily 1. Okay, so invalid part would be 57. If it's a 57, it should rejected. So partition, equivalence partitioning, it's partition. It makes the divide your input, your acceptance input between invalid, valid, and invalid format. It's similar like based on mean and max, but in a boundary value, like over here you do a mean +1, and then over here you do also you do a test on max level, like before max and after max. Over here in the mean level, before mean and after mean, and that is the middle. But in a boundary, in a partitioning, you do 3 part: invalid. So invalid, it means from the mean -1, so that will be invalid, it should be rejected. And then there will be valid part between the 18 and 56, whatever you want. And then and also in the max level, there will be invalid part after the max, right? After the max, like if it's 56, if you add 1, so it will be rejected or invalid part. So that's the most you can do. So it's minimize your test cases, okay, following this technique. So during the interview, if they give you like something like a character or number, something in a field, and then they said like how you are going to design your test cases, or what will be the combination of test cases, that time you will say, okay, whether I will follow equivalence partitioning or boundary value technique to design my test cases. Clear?
Okay, clear.
So similar, like there is a few more other techniques like decision table. You can go through it and you can find, if you have more question, we'll talk in the next class. Okay, let's go back to here. So let's now, those are the techniques. So using those technique, we write our test cases, like whatever the test cases, like different type of functional test cases: smoke, sanity, end-to-end regression. Let's talk about a little bit about the different type of functional testing. So one is smoke and sanity test. So smoke and sanity test, it's usually smoke test, it's a number of very high level test cases that cover your whole system, but it's very high level, not in details. Starting launching your application, logging probably just a happy path, and it's touch mostly like your core function to make sure those function is working, but it's not in details, but it's coverage your whole system. It's a very high level point of view. So number of test cases, maybe 100 test cases, maybe 80 test cases, and this number of test cases usually run every time in a schedule basis. Maybe it's run every night, and in the morning you see there is a report. If there is an automation for the smoke test, or even the manual, you can perform anytime, but usually it's happen in before any release goes to the production. That's one of the reason we use smoke test. Or if you have a major build, okay, so that time the DAP team can request you, can you run a smoke test? But mostly it's a smoke test, it's run before the release is goes. So if you don't have the release testing, so that the first people they create a smoke test, and then eventually they build the regression test. So it's and if there is automation, it's run on a schedule basis, just to make sure whatever the the developer they're working in, it's make sure that your system is working fine. On the other hand, sanity test is very close to a smoke test. It's the same number of tests, you can say it's a sanity, but the purpose of use case of the sanity test is different. It's only they use the sanity test, or they run the sanity test, it's for the minor code changes. If there is a bug found by the testing team and they resolve it, and then probably developer, they know it may break some other part of the system, they can say, okay, can you run the sanity test? So sanity test could be a little bit smaller than a smoke test, because it is mostly run for the minor code changes. When the minor code changes happen, there will be build, after that there will be build, and then based on this new build you can run a sanity test. Okay. On the other hand, a smoke test, as I said, like it can go for before the release. So you say you have a release, and you have a release, say 500 test cases, and then and that's it's a detailed test cases. It's a number of the most biggest number of test cases is the release testing or end-to-end testing. So if you have an automate for a smoke test, a smoke project, you can run your smoke test right away to make sure that on a high level point of view your system is working fine. But if there's some breaks you find, some bug you find, then you don't have to waste your time to run your release testing. So that's the way smoke test can help you, to benefit you, to save you time before start the release testing. But sanity test, usually when there's a minor bugs or minor fix, by whatever it's from the developer team, you can perform a sanity test. So that's the main difference. But a lot of times we mixed up in the industry. They said, okay, always either they say it's smoke test or they say always sanity test. It's a number of test cases between smoke and sanity pretty much almost same. Sanity test could have a little bit low number from the smoke test, but almost same number of test cases you can run between for the both sanity and smoke. Okay. And then retesting and regression. So retesting, if a tester found a bug on a module, one of the segment of your application, say example purchase module. So your application, you have a logging module, and after that so you can search product, and then you can purchase, you can add, there's a purchase, so it's you say is a purchase is one of the module. So if a tester found a bug on a module and they file that bug, so once the bug is fixed by the developer, the tester need to retesting to verify whether the bug is related to the module is fixed or not. Okay. So and also tester need to redo a regression sometimes. So the regression comes with the retesting. That's why they said the difference between regression and retest. So in this case, regression, it means the module we found the bug, and it has some, with this module it has some dependency with another module. Maybe it's because purchase have a link with the finance module. So if you find a bug on a purchase, you have to confirm that your finance module is also working fine. So that's, if there is a dependency, that time you can do a regression test. So regression is like more coverage between multiple module, and it's a happen after you retest, your retest is done. So retest is only happen based on the bug. When you find a bug and the developer they fix the bug, and that time you have to take the ownership of the bug. It means you have to retest the bug to ensure whether bug is fixed or not. On the other hand, regression related with the retesting, because if through the retesting or through the fixing your bug, if your module, the bug we find on the module if it has some dependency with other module that can be impacted by the new fixing, by the new code change. So you have to do some sort of regression to cover all the dependency module, including the affected module. So that's called the regression test. Okay, in a lot of times we say regression also before it goes to the production. That's another, that you can see that's very commonly used. Okay, can you perform a regression before the release? A regression, on the other hand, you can say it's a release testing. But there is a technical, in terminology there is a little bit different. But the regression usually, that's why it's called broader. So it's broader, could be like based on one bug fixing or based on release testing. And then there's a couple of more testing terminology we use. Like there is a localization testing. Localization testing, or it's called L10N testing. It's interesting. The reason why they say L10N testing, because it's localization. It's a 10 character, and it's L. It started with the L. That's why L, and its a character is 10. That's why it's called 10, and it's a and it's a part of the testing. So localization is the software testing process for checking the localized version of a product for that particular culture or local settings. The areas affected by the localization testing are UI and content. So it means there's a lot of software we see in the market. They support, say example, in Canada, so we have a lot of software, especially government software. It support the multiple languages to give a specific culture, a specific area to support, say like Quebec or Montreal. They need to have, and it's a French support software. So if we build this software that support a specific area, that's called localizations testing. So you have to make sure it's your software is supporting Quebec language beside the English, and it's in regards when it's a translate, all of the instruction, everything, all the workflow in the software, or any specific part which is built for that for a Quebec region, for a specific region, a specific culture. So at that time you have to do some testing. It's called localization testing. So on the other hand, there is a globalization or international testing. It's to ensure that application can function in any culture. So since it's globalization, so it can work on any culture, any language, multiple languages, not only the one or two languages. Localization is based very specific, one culture is specific, one area. But globalization, it works if you run the application, whether it's in States or Canada or any other part of the global, it should work. It should support that language. If you run that application in a specific area, say it's probably Germany, it should show that there is an option in German language. So this is called globalization. Okay, so globalization big, it's pretty big. Or if it's a one common the language, so it's support only the English, which is it's acceptable everywhere, which is a globalization. Okay, so that's that globalization. So mostly you will see a lot of company, they do a localization testing. So and there is an expert for localization testing, because you have to know that a specific language, the culture, to do the localization testing. There is a software even in the market to do the localization testing. So you can do a localization testing two different ways. So you can hire someone expert, which is like if we talk about French, like from the Quebec region, right? So you can hire someone individual expert who can go through the specific part of the application that's supposed to support the localization of Quebec language, each and every area. Or there is also tools in the market that you can automate, you can test your application to make sure it support the localization or a specific language. Okay, there's an end-to-end testing. So what is end-to-end testing? So testing overall functionalities of the system among all the modules is called end-to-end. So it's very simple. End-to-end means it's the whole system. It's cover all the modules from the launching to end. Okay, so there will be some workflow from one after another. So you have to you have to follow the whole user experience from the beginning to end, and so you should have a detailed test cases. So end-to-end test case, you can say testing, or it's a regression also. Usually before its release goes to production, we perform regression or release testing. It's a release testing is nothing, it's called end-to-end testing. That's cover your whole system end to end. Okay, here is an example. Say this is very simple. So you have a few module or function on your application. You have a login, and then you have a add customer, and then you can edit the customer info, you can delete the customer, and then there is a logout. So there is a 1 2 3 4 5 function on your application. This is your application journey, workflow journey. Okay, login, then add new customer, edit customer, delete customer, logout. Okay, so you should have a, for if I consider end-to-end testing for this application, you should have a number of test cases. It means before number of test cases, you should have a scenarios, different scenarios to cover login, different scenarios, add new test customer, scenarios for edit customer, scenarios for delete customer, scenarios for logout. And based on all the scenarios, each and scenarios, either whether it's one scenario or two scenario, based on each and every scenario for each and every individual function, you need to break down your test cases. So one scenario could have a one test case, one scenario could have multiple test cases. It really depends on you how you want to design. But understanding that's why its requirement comes very important. So the more the requirement will be clear, your scenario will be clear, and your scenario will be clear, you can easily break down your test cases. Then you can write your test cases one, or multiple. It's totally up to you. Okay, so all the different scenarios that will cover each and every functionality, all together, all the test cases together, we can tell this is a end-to-end test coverage. So you have an end-to-end test coverage. So before release goes to the production, you can run all the test cases from the beginning of your application, which is the logging to up to logout. Okay, so that's the end-to-end testing. Now we've seen over here in a V model, like there is a development life cycle, and other side we see it in a tester life cycle. So whether whatever the development model, whether it's a B model or waterfall or agile, there will be always number of activities from the tester life cycle, number of action that the tester usually follow to ensure all that the testing is being covered from beginning to end, whether it's like integration, system, or other test casing, functional, non-functional, so all the different number of activities tester usually follow, to define their testing process. So testing process is nothing, it's called software test life cycle, breakdown of the software test life cycle. And the more you have a clear software test life cycle or different phase of software test life cycle, you will have a better testing process. So what is SDLC? So SDLC, as I said, it's a number of activities, different activities that's followed by the tester to ensure the test coverage for your system and to deliver a better quality product. So SDLC has the following different phase. There's a number of phase that's involved, and in each and every phase the tester performs some activities. Okay, so here is a number of, but it's not mandatory all of the phase all the company they follow, but this is very generic. So whatever the model they follow, whether it's B model, waterfall, or agile, these are the main testing life cycle, the phase, the different phase. And as I said, it's every phase there will be some activities. Let's go through all of them, but it could be a little bit change, or could be some of the company they can I will explain the what part of the company they can avoid. But mostly the main the phase in software testing lifecycle, it's started over here, requirement analysis. This is the first phase. Then it's the testing planning, then it's a test case design, or test designing phase, then test environment setup, then test execution, and after that there is a defect reporting and tracking, and then the last is test closure phase. Okay, so let's go break down each and every phase. What's the input, what kind of action or activities tester usually do, whose responsibilities of what in testing team. Because the testing team, there is a QA, there is a QC, there is a team lead, could be the test manager. Okay, so it's a different, there is a number of people in testing team, so they have some responsibilities in each and every phase. And what's the final outcome for this specific phase, what's the goal we're going to achieve. So number one, as I said, is a requirement analysis. So input is FRS, which is it's a requirement specification. There's a CRS, is customer requirement specification. In nowadays in Agile it's called epic or story. Those are all requirement, some document. Those are the input in requirement analysis, and in those input or those requirement or those document, there was just using those document, the tester team, they will do some activities. What's the activities? They will analyze the requirement in details. They'll identify type of testing to be performed, like what type of test there was. So first they will analyze the requirement. So like epic or story or functional requirement, they will go through the requirement. They will try to understand the technical requirement, the use case of requirement, the acceptance criteria. They will try their best to understand the requirement. And if they need remember this walkthrough, if they have some unclear requirement or acceptance criteria, they will ask the product owner or the product manager. So okay, can you walk through me about this requirement? I'm not clear about the acceptance criteria. Because this is the first things we have to understand, the requirement, right? So this is the requirement analysis that happen over here. And after that, they, based on their understanding the requirement, they identify type of testing to be performed. What type of testing we're going to perform? Like, is that a functional test, non-functional test, performance test, is that a manual test? And also if there is a automation is possible, they also make a decision over here. Are we going to do how many tests we're going to, is that possible to do automate or not? Okay, or we're going to do everything manual. So during this phase they also do all this kind of activities. And the responsibilities, the team lead or test lead, they will do 60%, because here is over here there is a like decision making one things, like whether is automation would be done or not. And the requirement, the team lead, they have to know very well, the team lead, even though the tester, they have to understand the requirement also. That's why the test engineer, their part is 40%. But over here some decision making things happen, identifying the type of testing like we're going to perform. Okay, so this comes from the team lead managers, team lead. So that's why it's a team lead. It's their responsible 60%, and engineering they're responsible 40% in regards to understanding a requirement very details and clear. Because based on that, QA or test engineer, they are writing the test cases, they will execute. So they have to understand the requirement very well. So what's the outcome or achievement? It's like complete requirement, or DOR. DOR nowadays in Agile they use definition of ready. Definition ready, it means the requirement is very clear and acceptance criteria is very clear and understandable. So we have to confirm that we are very clear for the requirement. So this is the outcome or achievement. And automation feasibility report if it's required. If the automation is possible, so it will be also confirmed over here. That's the outcome. Next phase for STLC, it's a test planning. So in test planning, it's nothing, it's a larger document. Usually they do in document like probably Word, or nowadays there's a tools in Jira, they have a tools like Confluence, and in Confluence you can create your test plan up there. So it is a documentation. So it give you overall 3 answer. what to test, how to test, when to test. So it gives you the three answers. What to test, it means what function we're going to test. That you have to know. That's why you have to understand first requirement. Then you will narrow down, okay, what functions we're going to test. Then how to test, how we're going to test. Is that going to be automate? Is that going to be manual? Okay, is that is that a functional testing or non-functional testing? And when to test, when we're going to schedule, when we need to start, there's a deadline, and then when we have to deliver, when we have to complete, so those are all those things mentioned underneath the test plan document. What's the input? Definitely your project plan, your functional requirement. Requirement is the input in test plan, because so without the requirement you can't do the test plan. The requirement will tell you not only the the user expectation, but also your project will tell you also some deadline about your project. When need to start, when need to deliver, all those things, when you are committed to finish or testing, all those things. So those are the input for creating your test plan. Activities is from the testing team to create the test plan. Identify the resource. You have to make sure that you have all the resource. It means all the document, like functional project, all those documents you have available. Team format, who's working in manual testing, who's working on the automation testing, or you have available resource. Test estimation, how long the test will need, and based on that what will be the expense, because every hour it's cost money, right? So how many business days we need to perform for this coverage, for all this the test coverage. So based on that what would be the expense. So it is, and then preparation for test plan, all the requirements again, and then review of the test plan. After you complete the test plan, there will be someone who will have to review it, and then test plan sign off. Also it's part of the management, like test manager, usually they sign off. He confirm that okay, this test plan looks good to me, you can follow it moving forward. So here are the responsibilities: team lead and test manager, because mostly over here it's management work, like sign off, review, preparation, decision, like who's working on manual, who's working on automation, all those things. So that's why the team lead is the 70% responsibilities for these activities, and test manager is 30%. Specifically over here, review and sign off is done by the test manager. And then outcome is a test plan document. So your complete test plan document will be done following this test planning phase, during the test planning phase. Next, test design. Test design, it again over here your input would be your project plan, your functional requirements. So requirement is the source of one of the main source of your test design, because without it requirement you can't do the test design, where your activities would be preparation of test scenarios. As I said, during the test design you are going to break down the scenarios. Like think about the login function, right? Your scenario is like positive scenario, negative scenario. Your positive and negative scenario will be based on your requirement, because if you know the requirement very well, then you can divide it as positive and negative scenarios. So your scenarios, it's breaking down the scenarios, it's happening test design. Okay, and also over here what happened, preparation of test cases, and break down the test scenarios. You are going to use your test, you create your test cases, and then there will be review. Your test cases have to review, and there is a one important thing that happen, the activities in test design is called traceability matrix. So traceability matrix is nothing, it's another document, you can say in an Excel format. Nowadays is the tools, the test management tools we use, it comes to the traceability matrix function. What it does, it is like Excel sheet where it help you to map the between the requirement and the test cases. Like what's the number of requirement you have, and you have the test coverage, parallel test coverage, mapping the test coverage. So it's give you the clear list. Okay, here is a logging function, here is the number of test cases, number of test cases 1 2 3 4, here is the number of test cases. So it give you the direct, so you can share this traceability matrix with your client, with your upper management, so that they don't have to go to your test management tool and break down where all the test cases do have the coverage or not. The traceability matrix is one of the very important document, whether for your upper management or for the end client, that give them satisfaction that okay, I have the good coverage test cases according to my requirements. So it is the map between the requirement and test coverage. Okay, previously we used to make the traceability matrix using Excel sheet. Now all the test management tools comes with the default feature. It's called traceability matrix, you can use. Okay, so in this testing designs, because over here we already know our scenarios, we already know our test cases, so right away we can create our traceability matrix, and at the end there will be also test case sign off from the team lead. Team lead will confirm okay, the test cases, test scenarios you have breakdown, it is right. Okay, and here now and also one thing is for the test designing, and also there is a couple of more input is like test plan, and definitely as per the test plan you are going to design your test cases. So design documents is also one of the input over here. Design documents, it means remember there's a low level design in one of the phase of development happen, which is the UX design. So those design, UX design, it means like the UX developer, they will make some mock design levels, like they will make some your as per the application how should looks like a login function page, where should be the button, what should output when you click the button, all those things. They create a UX design following different tools in the market. Like Figma is one of the tools in the market, very famous UX design they use. So they will share beside your requirement, beside your functional requirement, like document in the UX design, a document, it will give you the more clear view about your requirement or acceptance criteria. So those are the input use in test designing phase. So what's the responsibilities over here? Responsible for the testing team or team lead is 30%. Over here test engineer is 70%, because over here we're going to break down create the scenarios, and then based on the scenarios we're going to prepare the test cases. So those are the pure activities of the test engineers, and it's a lot of works over here. And other than also the creating the traceability matrix, the review part, sign up part is from the team lead or test lead. So that's why it's a little work. It's a 30% of the team lead's responsibilities. And what's the output, final outcome from this phase test design is traceability matrix. It's one of the achievement, and also writing your test case document. You have been able to break down your scenarios and write the test cases. That's the output. Now when your test case is done, next phase is test environment setup. Test environment, because before you execute test cases you have to ensure you have the right environment with the right build. So what's the input over here? Understanding the requirement architecture, like for your to ensure that you have the right test environment. Most of the company, they have the separate testing environment, or it's called test staging environment or QA environment. Okay, and QA environment is always gets updated with the latest build. When the developer work on the new new changes, or even it's a fix any bug, they update the dev environment. Besides, they have to confirm that your test environment is also up to date. So understanding the required architecture, the technical architecture is the input. Over here, the activities for the test environment setup is prepare hardware and software list. It's for the test environment you need the right number of hardware. Like if there's a mobile automation or mobile testing, you need the right number of mobile devices or different tabs, and also for the different operating systems you need virtual machine or whatever so it's a list of hardware, and also you need the software list. It's like latest build. You confirm that on your you have that latest build is done by the developer and it's available so that you can test on your environment. right? Setup test environment and test data. Also the testing data is also have to make sure during that test environment. So what combination, what number of test data you need for testing the whether it's new features or fixing a bug. Okay, you have to ensure during that time. And perform a smoke test on the new build. So when a new build is it's giving you like exe format, usually like its new build is nothing like whatever the new change they inject the developer on their application, and then they will give you executable file. You will download that executable file, and it has the latest code. And on that code, if you have a smoke test, that's why smoke test is very important, right? A smoke test that you can perform your smoke test just to have a very high level idea the application is working fine, it's not breaking, before you deep dive details testing, details more functional testing or release testing on that environment. Okay, so that's the activities usually it does. But here is the one thing is like test environment setup is not fixed, like activities is not fixed, like this is the fully responsibilities by the the QA team. Sometimes like a developer, it depends on the company. Sometimes with the company they have the DevOps engineer, they ensure the test environment it's up to date with the latest code. Or the developer, even say you have a 3 different developer, they are working in 3 different features, and for 3 different features what they do, they create, after they develop, they also create a testing environment, or it's called preview environment. Okay, preview environment, so it means each and every developer, whatever the features they are working for, that is specific feature, they will create, every developer or every individual developer, they will create a preview environment, and they will share the link with you so that you can only test that specific features for that specific on that specific environment, and it will be disappear. They will kill that environment after the testing is done. So sometimes some company they do this kind of pattern. So developer will create that time the preview or testing environment for you, which is temporary, but this is the one of the fixed testing environment, like a staging environment, like you will perform like release testing or even functional testing. It depends on company. So it's not means like the tester will build the environment, but it's their responsibility at least to ensure the environment is up to date, the new build already in deployed to this environment, whether through the developer or through the DevOps engineer. Okay, but rest of the things they have to, like test data, this is a pure responsibility by the tester, and also performing smoke test. Okay, so here the team lead responsibility is 70% and test engineer is 30%, because team lead will ensure will communicate all the communication with the developer or the DevOps engineer to ensure the test environment it's up to date, and the test engineer will perform the smoke test, also ensure the test data also is responsible by the team lead. Also it's both team lead and engineer. And what's the output? Output is environment is your test environment is ready and up to date, and a smoke test you will find some smoke test result. That's the output through this phase. And a smoke test, if it is smoke test it's all pass, it means your environment is good, you can do more or further, or you can deep drive more testing on there. If it's a fail, then you don't have to waste your time, you can work on that. Okay, especially that those failed. Next phase is test execution. So after your test environment is ready, now it's time to execute all the test cases you have been created, you have been written. So your input would be for this phase, the input would be functional requirement. Definitely your requirement, you have to make sure you have the requirement before and based on requirement you have created test design, you have break down the scenarios and have been written the test cases. So test plan is one of them. Your input. Test cases is your input, because you are going to execute test cases. Without test cases you can't execute it, right? And test environment with the latest build. So those are your input for test execution, or prerequisite you can say. The activities, what's the activities? Execute the test cases. That's the pure activities during the test execution. Prepare for test report or test log. if you find any bug, you will file the bug. Okay, that's the that's you can say it's a test log or test report. So test report would be like after you finish, there will be number of bugs if you find. So identifying bug and report those, it's your test, it's activities. And here is a team lead job is very less. It's a 10%, mostly test engineer, because they are the main person who write the test cases, execute, file the bug, and track the bug, and identify bug, all those things. And the main output from this phase is status or test report. The test report, where it will tell you like number of test cases you executed, number of test cases was passed, number of test cases was failed. So pass rate, fail rate, execution rate, everything will be over here through the status report, right, or test report. Then the next phase is after your execution. Definitely if you find some bug, the bug defect reporting and tracking is your next phase. Over here your input would be your test cases and this test report, because in test report you will say not only your pass rate, fail rate, but also you will say your your bug also. Like fail rate is a part of that. It's a defect, right? So defect comes through the fail rate. So and main activities over here, prepare. So whatever the defect you found, you are going to prepare the defect report. You will combine all of them, make a report. Okay, I found 5 bugs. Okay, here is all the list of the bugs. So this is the report of the the defects. And then after you file a bug, you will assign that bug, whether it's a developer, specific developer, individual developer who is was working on that specific features, or the product owner or product manager. You will talk to the product owner, and then as per his concern, whether you will assign that bug directly to the developer if needs to fix now, or it will go back to the backlog, and that the product owner will make a plan on later on, or for upcoming session, upcoming sprint. Okay, so this is the defect. So as per the product owner's concern, you will whether assign that bug or not to the developer. And then here again, test leads activities very less. It's only 10%. Mostly it's all the activities done by the test engineer, which is the 90%. And by the defect reporting over here, by doing this, our main achievement would be defect report, where we'll tell you all the defect you found, number of defect, the defect list, the link of all of the defect you have filed, and also you can track. In this phase you can say defect reporting and tracking also. So tracking should be part of over here too, because when you file a defect, you own the defect. It means you track it when it gets resolved, and after it's resolved, you have to retest. Remember we talk about the retest, so its retest should be part of over here too. Okay, so this phase is complete, would be defect reporting and tracking. That's what my understanding. And then last part, after defect is done, in the last part would be test closure or sign off. Here your input would be defect report. Whatever your defect number, defect you found, this would be your input. And then test report. Also the test report, like pass rate, fail rate. Test report shows your pass rate, fail rate, and defect report shows you all the defects, number of defect you found, and you filed, all those things. So this two report is the part of in input was work as an input for the test closure. Here we work what's the activities analyzing all the both reports. Okay, so like defect reports and test report, analyze the bug reports and evaluate exit criteria. There is a, before you finish your project, as per testing, there is a exit criteria. You can say your testing is done. When you can say your testing is done, after you definitely complete your test execution, you find the different type of report, that time you can say your testing is done. But what's how you can say your testing is done is that a cover was 100% coverage. So there will be some criteria to ensure you can confirm our testing is done. Like your pass rate could be you execute 100% test cases. So that's one of the exit criteria. And then that could be it depends on your company's standard, but on an average the exit criteria for a testing a project, it's like try to execute 100% test cases. Could be some exceptions. Sometimes there is some test cases could be blocked, for dependency. Those are other, different consideration, but usually it's 100% execution. Pass rate, you can say, it's probably at least 90%. If the product is below 90%, you cannot say the product is good. So it needs more testing. If whatever the bugs you found, if the bug is, you get a lot of critical bugs, or even one critical bugs, that time you have to make sure that bug is fixed. Until it's fixed, it means until you retest it, your testing shouldn't be closed. So following this some exit criteria, the test manager will sign off this test project, testing, okay, for this project or for this release the testing is done. So the sign off is one of the big part over here as an activities for the test closer. And here test lead or manager, the responsibility 70%, and test engineer is 30%, because mostly over here analyzing the bug or report, different type of report is found by the test engineer, and they will sign up. They will, based on their sign up, their confirmation, there will be release goes to the production, or it will be hand over to the end client. And what's the outcome of that? The test closer, by the test closer, there will be complete test summary report. It will be combination of two report, your defect report, your test report. And over here in test summary report will tell you exactly the similar things like a pass rate, fail rate, and a fixing rate. There will be some fixing rate over here too, your bug rate, or the list of the bug, and also the fixing the bug. It will also mention over here, and it will tell you at the end, okay, it can go or no go. Okay, so this is the complete test summary report which comes through the test closer phase. So that's the overall, it's called software test life cycle, all different activities and different phase. And this is all the phase. This software testing life cycle is follows whatever the development model they follow, the adaptive, whether it's a V model or waterfall model or agile model. Okay, this is all those things is follows, but the time frame would be different. Here is the interesting part is the time frame. We'll talk in our next class about the waterfall and agile, and then from the agile we'll deep dive the agile methodologies, and we'll do one or couple of project where we're following the agile methodologies. We'll do some testing, and we'll apply some of the testing concept. Okay, so this is one of the important part over here, understanding the very details and very clear about the software testing life cycle, which is the testing, the process is define your test process. Okay, and also all the different types of different types of testing that we use as a tester, and some terminology that's used in our testing industry or development industry. Clear?